Okay, so today we're going to talk about the molecular geometry of molecules. So that's basically just looking at what shape is this molecule going to be. So the theory that we're going to go by is the valence shell electron pair repulsion theory, which is commonly known as Vsepr. So valence shell electron pair repulsion. So what is this name even telling us? It's telling us that the electron pairs, so the lone pairs, in the valence shell want to get as far away as possible from each other. Why is that? Because electrons all have negative charges, and two negative charges don't want to be close together. So they're going to form in a way that they are far apart from other electrons as possible. So if you turn to the next page and the page after that in your homework packet, you're going to see the Vsepr theory. And it lists different types of pictures, so those are kind of like your lowest structures. And then it's going to go for bonded atoms, the amount of lone pairs, and then the molecular shape. That's the shape that we're worrying about, the molecular shape of it. Electron geometry we're not going to get into all that much. That's just the overall shape of the molecule, but what we're concerned with is the molecular shape. So we're going to follow this chart for now, but you do have to memorize these. This is not in your reference packet. It cannot be found anywhere. These are the shapes that you're going to have to memorize based on the amount of lone pairs and bonded atoms that there are. So let's do a practice problem here. Methane. So I told you here that methane's formula is CH4. So what we want to do first is draw the Lewis structure. First thing we do when we draw the Lewis structure is figure out the number of valence electrons. Carbon has 4. Each hydrogen has 4. So that means we're going to have 8. If we count out the amount of electrons that are being used in this molecule, 2, 4, 6, 8. So we're good. Bonded atoms. How many atoms are bonded? We have 5 bonded atoms here. Actually, what we're going to do is, if you go to your chart here, we're going to count the number of bonded atoms to the center atom. So we have 4 bonded atoms, and we have no lone pairs here. We go to our chart, where it says 4 bonded atoms and 0 lone pairs. The shape is tetrahedral. So just going through that once again. First we're going to draw a Lewis structure using the rules that we learned on how to draw Lewis structures. Then to get the number of bonded atoms, you're counting the number of atoms that are bonded to the central atom. So in this case it's 1, 2, 3, 4. We have no lone pairs, so there was no dots on the outside of carbon. So that's 0. We look that up in our chart. 4, 0 is tetrahedral. Let's try another one. So ammonia. I told you here the formula was NH3. So let's figure out the number of valence electrons that we have here. N has 5 valence electrons. Each hydrogen will have 1 times 3 is 3. So that's going to give us 8 valence electrons. So we have nitrogen, and then we're going to have 3 hydrogens attached to it. And we know that our nitrogen needs to have 4 things around it. Right now it only has 3. So we have to add a set of lone pairs. So now let's count our electrons. 2, 4, 6, 8, which is the same as the number of valence electrons that we calculated. Now we look at the number of bonded atoms. There's 1, 2, 3 hydrogens bonded to the nitrogen. And we have 1 set of lone pairs. If we go to our chart, we go to where it's 3 and 1, so 3 bonded atoms, 1 lone pair, and it's trigonal pyramid. Trigonal pyramid. So that's the shape that you'll be responsible for when you have a structure that looks like this. Alright, let's do water. Note the formula for water is H2O. Hydrogen each has 1 valence electron, so that's 2 for hydrogen. Oxygen has 6. So this one also has 8 valence electrons. You have an oxygen that's going to be bonded to 2 hydrogens. Right now we only have 2 things attached to our oxygen. We know that we need 4, so we have to add 2 sets of lone pairs. Number of bonded atoms to oxygen, that's 2. The number of lone pairs to oxygen, that's 2 as well. So our shape, if we go to our chart, we're looking for 2 bonded atoms, 2 lone pairs. The shape of that is bent. Alright, so what takes up more space around the central atom, a bonding pair or a lone pair? In our lone pair, we have 2 free electrons. Those 2 are going to try to go away from each other as much as possible. So our lone pairs are going to take up more space than our bonding pairs. Number 6 has 6 more examples for you to try. Get those done and come in with those done in class tomorrow, and we're going to go over these answers and make sure you have a good understanding of this. Like I said, you do have to remember all of these shapes. I would suggest making flashcards. It's probably going to be your best bet in order to memorize them.